Okay, so this is the first question. Now, this question is on kinematics. Okay, it's on this thing called the time of flight. Okay, so two projectiles are launched with identical speeds at an angle of 40 degrees and 50 degrees with the horizontal. What is the difference in the flight times between the two projectiles? Now, we can actually derive a generic formula for the time of flight. So the time of flight, right, is more of defined as the time it takes from this point all the way to this point. Okay, so from year to year, that's the time of flight. We can see that if we use SUVAT, now in general, let's let the initial speed be U. So this will be U sine theta, okay, where theta is angle to the horizontal. This will be 0 because come back to the original spot. Okay, we look at the vertical direction. And if we take upwards positive, this will be negative G. G is 9.81. We're supposed to find the time. So SUAT, you can see that 0 is equals to U sine theta T minus half GT squared. Okay, UT plus half AT squared. We are using this formula. Okay, this 0, let me make it nicer. Okay, so from here you can see that T is equal to 0 or T is equal to 2U sine theta over G. So in general, this is the formula for the time of flight. I mean, it can be memorized or it can be derived. You can see that the derivation is pretty quick. Okay, so now we talk about the two projectiles. The first projectile, let's put it as T1. Okay, now T1, for the first projectile, for the 40 degrees one, is 2 times 30 sine 40 degrees over G. Whereas for the 50 degrees one, T2 is equal to 2 30 sine 50 degrees over G. So you press calculator for this two. Okay, make sure your calculator is in degree mode. That's one of the most common colors. So 60 sine 40 divided by 9.81, you will get 3.9314 seconds. And for the second one, okay, it's the same as 50 degrees. It will become 4.68529. And if you take the difference, T2 minus T1, it will give you 0.753. 0.7539. Okay, 2SF is around 0.75. Now 0.75, of course, when you look back, it's going to be closest to B. Okay, this is 0.75. This is actually 0.8. It's pretty close, but you can see 0.7539 is closest to 0.75. Okay, this is going to be 0.67. 5 divided by 6, okay, if you can just use calculator, 0.83. And 6 divided by 7 is 0.86. Okay, so it's closest to answer B. That's for question 1. Okay, kinematics question 1. Okay, so the next question that was asked, question 7. Now, student drifting down Singapore River is assumed to be straight. The Singapore River is assumed to be straight with a current of 0.75 meters per second and falls off his raft. He grabs a piling of Coleman Bridge beside him and holds on for 40 seconds. He then swims after the raft with a speed relative to the water, 0.95 seconds. So you take note, there's relative speed here. So the distance of the raft downstream when the student catches it is. Okay, so for this story, okay, first, he dropped down the raft, he held for 40 seconds, and the raft continued moving at this speed. So he holds on for 40 seconds. At the end of 40 seconds, what is happening? Okay, so the student is still here. This is the bridge, the start point. Okay, and then at this particular time, the raft is 40 seconds times 0.75. This distance is 0.75. Okay, times 40 is equals to 30 meters. So when he releases and swims after the raft, he now starts at 30 meters behind the raft. Relative speed of 0.95 meters per second means he's going to swim faster by 0.95. Okay, so in a way, what happens is that this student will need to swim faster than the rough by he swims faster than the rough by 0.95, and he needs to cover extra 30 meters. So as the rough is moving down, okay, as the rough continues to move down, this is the start point. As the rough continues to move down, the student is now catching up. Okay, now this extra 30 meters that he's going to catch up, the time taken for the student to catch up, okay, this is for catching up. Okay, the time taken will be 30 divided by 0.95. Okay, so this is the distance over the speed. So you get 31.5789. So he needs to swim at this for this amount of time to catch up the rough. Now, what happens is that he's actually swimming 0.75 plus 0.95, which is actually 1.7 meters per second. But I'm using the relative speed because I don't know this distance. Okay, so it's easier to calculate this way. So now that you have this time, this is the extra time for this red color here. What's the distance traveled by rough? And this will be 0.75 times 31.5789. This should give you 23.7 meters. So we know that this is 23.7. This is 30. So the total distance is 30 plus 23.7. So it is 53.7, or rounded off, it's going to be 54. Okay, so answer is A. Okay, next question. Okay, so the next question that was asked was question 8. So a juggler throws a ball into the air. He throws one whenever the previous one is at the highest point. How high do the balls rise if he throws n balls each second? Okay. In other words, the frequency is n, or the period is 1 over n, which means that the time it takes for the ball to go to the highest point is going to be 1 over n. Okay, because he throws one whenever the previous one is at the highest point. Okay, so from the bottom to the highest point. Okay. So let me draw out the thing now. So from the bottom to the highest point, you will go up with a, let's say with a speed u, go up to the highest point. And here, it is momentarily at rest, comes down. Okay, now the thing is that we are supposed to find this height. How far do they rise? Okay, now of all the 4 formulas, right, you'll realize that if I look at this portion, I will actually get SUVAT. Now let this be U, this is 0, taking outwards positive. Here will be negative G. Time is going to be 1 over n. I need to find this. Okay, but of all the 4 kinematics formula, each one has U. And it's actually going to be complicated to do this. So it's actually going to be easier if we look at the downwards component. Now the downwards component, right, the time taken will be the same as the time it takes to go up. Okay, the time taken to come down is the same as the time it takes to go up. If you draw the VT graph based on O-levels understanding, okay, assuming there is no air resistance, we are going to get this very straight line, and the area here will be equal to this area here for it when it comes down. This is the highest point. Okay, so by playing with this, now we can see that, okay, now if we go by the downwards component, we also need to find a height. Now, if we take downwards positive also, SUVAT, now the time is still 1 over n. Now this is going to be G. This is going to be H, which we want to find. And this initial speed is 0. So with this, we now can use S equals to UT plus half AT squared. H equals to 0 plus half G 1 over n square. So because of that, you get G over 2N squared. And based on this, you can see that answer C is the answer. Okay. Okay, so now let's move on to the next question. Okay, so this next question on circular motion. A tether ball is on a 2.1 meter string and makes an angle of 22 degrees with the vertical as it moves around the pole in a horizontal plane. If the mass of the ball is 1.3 kg, what is the ball speed? So it is what's happening. This is 22 degrees. It's 2.1 meters. And this is the ball. So it moves around in a horizontal plane. So let's draw out the free body diagram for this ball. So there is just its weight and the tension. Okay. Now take note that this portion here is the radius of the rotation. And because of this triangle here, okay, this is the center of the circle, we can see that the radius is actually going to be 2.1 sine 22 degrees. Okay, so back to the calculations. Now, if you look at the free body diagram, our T cosine 22 degrees, which is the vertical component of the tension, is equal to the weight. The horizontal component of the tension gives you the centripetal force. Okay, we use this because we want to find speed, which is V. So this is equation 1, this is equation 2. And the same thing, 2 divided by 1, as in the notes. Tangent 22 equals to V squared over GR. And this is also equals to V squared over GR is 2.1 sine 22 degrees. Okay, now just key everything into your calculator. You'll get your V as 1.766 meters per second. Okay, I put more SF for you to follow. So you can see that the answer is going to be C, 1.8. Okay, so that is for question 3. Okay, next. Circular motion. Okay, 2015 question 26. Two identical masses, A and B, are tied to strings and placed on horizontal frictionless discs, as is in the figure below. Now, the two masses are then set to move about the center of the disc with the same angular velocity. Given the tension connecting A to the center of the ear, this tension here is going to be T. Determine the tension of the string connecting B to A. So now, this question, okay, the acceleration is towards the left. So it's similar to the Newton's third law kind of question, where you have A, B, then after you have pulled by a force. Similar, but where is it different? Now, in the Newton's third law single direction type of question, the two masses have the same acceleration. But here, when the mass is different, even if it's the same, okay, when the angular velocity is the same, but the distance from the center is different, the acceleration, the centripetal acceleration is going to be different. So for A and B, now for A, let's draw the free body diagram of A and the free body diagram of B. We draw them separately. For A, we know that this is tension. They tell you this is T, but let it be F. We don't know. Okay, the resultant T minus F is equals to mr omega squared. For B, there is only the F, okay, which is by Newton's third law. It's a frictionless disc, so friction doesn't play a role. So this F and this F is Newton's third law. And F is equals to m3r omega squared. Identical mass, 3 times the radius, identical angular velocity. So this is 3mr omega square. So you can see that if I combine, right, I can actually see that this is actually this 3mr omega square, right? It's actually 3 times of the left one, 3t minus f. Okay, so rearrange for f equals 3t. So f is 3/4 t. So answer is just B. Okay, next one. 2016 question 17. 360 kg roller coaster is initially at rest at a height of 120 meters above the ground. It goes to the ground and does a circular loop of radius r. So assume the friction and energy losses are negligible. The car is small and not attached to the track. What is the maximum radius so that the roller coaster does not leave the track? So initially the roller coaster is here. Final is here. Okay, it's going down. Turn one big round. Now at this point, let it be V. We let it be V. So the thing is that, hey, if you recall, there's a minimum speed for it, for the card to remain in contact. Now, at this particular point, the free body diagram, there are only two forces acting on it is a normal contact force and its weight. So N plus mg equals mv squared over r. Now, at the minimum speed needed, okay, the maximum radius will give us the minimum speed because why? The loss in GP gives you the gain in K. So at the maximum possible radius, the speed will be at its minimum. Okay, so this is the distance I want to find later. Okay. So now for this, n is equal to 0 at its minimum speed. So we can say that therefore v squared is equal to gr. Okay, this is the minimum speed to remain in contact. So next, between this point, which at rest to this highest point of the loop, there's loss in GPE, which is equals to gain in KE. So mgh equals to half mv squared minus 0. Initial is going to be 0. And v squared is actually gr. So mgh equals to half mgr. Cancel. Okay, so from here, you can see that h equals to half r. Now, of course, we can't just solve this. There are two variables. So we want to find the value of r. Now, from here, you can actually see that at this point, h is the same as 120 minus 2r. Okay, this is the value we haven't used, so I need to go back and check. So I'm trying to use this value. Okay, 360 kg will not be used, I think. So 120 minus 2r, that's your h. Okay, because 2 times the radius here. So now plug back into here. 120 minus 2r equals to half r. Okay, so you'll see that 120 is equals to 5 over 2r, or r 0.4 times 120 is equals to 48 meters. So that is your answer, your radius, okay, which is answer C. The maximum radius so that it does not leave the track. Okay, so that is for the first part